Problems in calculus dealing with related rates and optimization often involve identifying one or two variables that are related by one or more equations, and quite often it involves solving an equation, finding a solution. And some of the problems that we're going to do below show up in a more complex form in the lectures in Calculus 1 on related rates and optimization. And the background knowledge you need to solve many of these problems involves basic areas of geometric shapes, rectangles, circles, triangles. You also need to know how similar triangles are related, Pythagoras' theorem, and volumes of basic shapes such as cylinders and boxes. And we have a full list of these results at the end of this section, which you should look over. The basic formula is the area of a square is s squared. Area of a rectangle is the length by the width. Area of a triangle is half the base by the height. The area of a disk or a circle, the interior of a circle, is pi r squared, where r is the radius and the circumference is given by 2 pi r, where r is the radius. Pythagoras' theorem says that if you have a right-angled triangle, the square and the hypotenuse is the sum of the squares and the other two sides. Volume of a cubed is L cubed, where L is the length of one of its sides. Volume of a box is A by C by B here, the length by the breadth by the width. And the volume of a cylinder is the area of the base times its height. So in this case it's pi r squared times the height A, h. And the surface area is the area of the base, actually both bases here, so plus the area of this region around the center, and the area of this region around the center is 2 pi r. If you just flatten this out, you get a rectangle of height h, and the length of one side is 2 pi r. And so you get 2 pi r h plus twice pi r squared, which is the area of the ends. And similar triangles are triangles, you can identify them in any number of ways, but for the most part they have two angles which are the same. Let's say theta and alpha. And these ones are right-angled triangles. And if those angles are the same, then let's call this one ABC, and this one D, E, and F. And then the sides are proportional. The length of AB over the corresponding side, the length of the corresponding side DE, is equal to the length of BC over the length of the corresponding side in the similar triangle, which is the length of AC over the length of DF, the corresponding side in the new triangle. So those are the theorems from geometry or basic algebra that you should remember. And quite often these word problems, as people often call them, involve some problem solving. And this is something you have to embrace with a little curiosity. And it's not always obvious what the solution to the problem is. Otherwise, it wouldn't really be a problem. So some tips to help. You should read the problem carefully. There's no surefire method of finding the solution. You should read the problem carefully. It always helps to draw a picture, identify the variables that you need to find and give them a name. Figure out what information you're given, and if you can write that down in algebraic format in terms of an equation. Write down any equations relating the unknown variables. And some equations might follow from geometric properties of your picture, or some may follow from the information that you're given, and then try to solve for the unknown variables. And basically, keep your wits about you and try to be rational. Again, I'd like to re-emphasize the tips for success that I pointed out in the last set of notes, and that is you should always write in complete mathematical sentences, just for your own sake, so that you can keep track of where you are when you're solving more complex problems. And when you do find a solution, you should reflect on your solution, figure out what it was that led you there, try to pull out any general principles that might be useful in the future, and if you don't arrive at a solution, and you happen to see the solution elsewhere, then try to figure out where you went wrong and how you can fix that for the future. Okay, and having said all of that, here's an actual example. It's not nearly as scary as it sounds. We have a 12-foot ladder leaning against a wall, and Jack pulls the base of the ladder away from the wall and stops when the base is 5 feet from the wall. What's the height of the top of the ladder above the ground when the base is 5 feet from the wall? Well, we have a picture. We'll assume it's a vertical wall, and we'll also assume that the ground is pretty level near the wall, and we have a ladder here leaning against the wall, and we're thinking about the ladder is 12 feet long, and Jack pulls the base out to 5 feet from the wall, and the question is, how high is the ladder on the wall when the base is 5 feet from the wall? So what's the height of the top of the ladder above the ground when the base is 5 feet from the wall? Well, it's probably fairly obvious if you've had a little geometry as to what to do. This is a right angle, and using Pythagoras' theorem, says the square in the hypotenuse is the sum of the squares on the other sides. And now that says that 144 minus 25 equals h squared. And that says that h is approximately, or is equal to, the square root of 119, and that's approximately equal to 10.91 feet. This symbol, the wavy equals, means approximately equal to. So the height of the top of this ladder above the ground in this situation is approximately 10.91 feet.